So yesterday we were continuing about the layman audience for this model development life cycle for bank fraud. So we went through some of the slides. I think up to 8 slides we went through, right? Test strategy was done. Uh, it was done, right? Test strategy. Or
Yes.
which one? Huh?
And okay, we should not
Datasets we discussed.
data set we have discussed. Yes.
Yes, train and validate test strategy we discussed it. Then we stopped it. So let us continue. Establish the baseline.
Okay.
Before trying complicated AI models, we first establish a baseline. Think of a baseline as our starting point. We build a relatively simple model, measure how well it performs, and then use that result as our benchmark. So this is also we discussed it actually. A simple model, then later on increasing all these things. Then eighth slide, evaluate candidate models. And this is usually a no single A algorithm that is automatically best for every fraud problem. Yeah, this is also we discussed it. We discussed it about the false alarms, miss frauds, all those things. Right. Then this is ninth one. We'll see solve the fraud imbalance problem. Fraud creates a special problem for AI. Imagine a bank has got 1 lakh transactions, but only a small number are actually fraudulent. Most transactions are legitimate. It is the fact if card is not being used for fraudulent purpose, this is the situation. A model could simply say legitimate almost every time, still achieve very high overall accuracy. It means because of the less transactions are there, fraudulent transactions, the model can perform high accuracy because of the size of density of the data, right? But that would be a terrible fraud model because it would miss the transactions we actually care about. So let us say it has got only 10% transactions out of 1 lakh records, right? Then you can't trust the model is going to work for real more fraudulent transactions, right? We need to change the scenario in such case, the data set scenario, right? Then imagine 99,500 transactions are legitimate and 500 are fraudulent. A model that calls everything legitimate could appear extremely accurate, but it catches none of the frauds. It means that fraudulent identification paths or model algorithms testing is not going to be possible completely because it is not having sufficient data to test the paths, right? Therefore, we need
Okay.
techniques that give enough importance to the smaller fraud population and carefully balance fraud detection against unnecessary customer alerts. So, that algorithm techniques need to be identified to trace the fraudulent transaction from the data sets. So simple takeaways for this slide: for fraud detection, catching the right transactions is more important than simply achieving high overall accuracy. I discussed with you yesterday in our Python scripts, we need to prepare more fraudulent transactions, less right transactions because our algorithm need to be tested it, obviously.
Yes.
So here also it is the same case for slide 9, right? Then slide 10 is model development loop. Model development is not a one-time activity. We build a model, test it, look at where it made mistakes, understand those mistakes, improve the features of model settings, and train it again. This is a continuous improvement cycle basically. So it means we are building a simple model as we discussed in the previous slides. We're testing it with some data set. Then look at where it made mistakes. It means there can be defects in the model. Then understand those mistakes. Yes, improve the features and model settings. The defects can be there because of the inconsistency of the data. Sufficient data is not there to test a model. It can be code problem, it can be data problem also, okay, for failures. and train
Yes.
it again and again with model settings, right?
Okay.
Yes. So explain the loop simply. First, we prepare the features, then we train the model, then we evaluate it, then we investigate the mistakes, we improve the model, then we train it again. It means it is a cyclic process which is in loop. That is called loop, model in
Okay.
loop, right?
Okay.
Then simple analogy is what? It is like teaching a child to recognize fraudulent transactions. Every mistake becomes another learning opportunity. If you take a below 1 year or 2 years kid, what happens? It will be teaching her any kind of things, how to eat, how to catch, how to walk, how to run, such kind of things. So if they are doing mistakes, we are going to show that. The same way he is comparing with kid training, right? We're also training the kids, right, in the beginning of their
Yeah,
life,
yeah. Yes.
the same way. So simple takeaway, train, evaluate, learn from mistakes, improve, retrain. The layer three, source material specifically frames model development as an iterative loop rather than a one-time build. That is the one. Okay. An outcome of that. Then slide 11 is risk score and decision threshold. The AI model can produce a risk score, but score itself is not necessarily the final decision. We have seen in some of the slides 70 to 90 with red mark, right? A risk score. So that itself is not denoting it. There are other parameters, factors we need to see. So imagine the model gives a transaction a risk score of 90 out of 100. The bank may define 0 to 40 as low risk, 40 to 70 as medium risk, and above 70 as high risk. Then low risk transactions might be allowed automatically. Medium risk transactions would be sent for additional verification. High risk transactions might be blocked or require stronger authentication. This is the risk score and decisions. So decisions are made from the risk. These are the parameters and intervals also, right? Then important architectural message is the model provides intelligence. Business policy converts the intelligence into an action. See, why business people are required here? They need to identify what are the risk categories, right? Incidents, when incidents appears, some guys are identifying into different levels. So high, medium, low, improvement. These are the four categories, right, in the incidents.
Okay. Yes. Yes.
So the same way, the risk scoring and decision threshold need to be made. These are the
Yes.
thresholds.
Correct.
Okay. Then important architectural message. The model provides intelligence. Business policy converts that intelligence into an action. It means whenever the models are giving the risk factors, the business need to identify that data. They need to take the decision to evaluate that particular record, right? AI gives that's where the human involvement is required within the models. There is a concept called frontier office in a artificial intelligence frontier office. In frontier office, what happens? Multiple agents are working, then human is going to review their work. The same way here it is applied. Okay. Then simple takeaways. A gives us the risk level. The bank decides what action that the level should trigger. Yes, these are the factors they decided with ranges of the risks to identify the decisions made it. Right. And slide 12 is evaluate the model like a bank. So now we need to ask a much more important question. Is this model actually useful for bank? Practically, we need to think like a business user when you
Okay.
are working with the
Obvious.
models. So we
Okay.
look at four basic outcomes. True
Mhm.
positive, the model correctly identifies fraud, that is the real function. Then false positive, a legitimate customer is incorrectly treated as suspicious. True negative is a legitimate transaction is correctly allowed. False negative is fraud happened, but the model fails to detect it. So these are the ways they need to identify it, right? Now, connect it to business. How? A false positive can frustrate a genuine customer. A false negative can result in financial loss. It means if true transactions are there, if they defined it as false, That is a problem with the customer, with the bank also. Again, if fraud transaction is there, if model is giving it is true transaction, that is also a risk. So internally unidentified risks are presented within the model because of model defect, because of data defect. Both ways. When bursts are happening, AI bubbles are happening, it can be a data defect, it can be a development defect. Both ways you can think it. You're getting right, Bharat?
Yeah.
Okay. Simple takeaway is what technical model metrics must ultimately translate into customer and business outcomes.
Yeah. Yeah.
The metrics, whatever we have seen in the previous slides, it translates into customer and business outcomes. What are the outcomes? Risk scores, example. Then false transactions, positive transactions. Those are the categories. These are going to be used by the business for positive decisions. But here,
Yes.
one thing we need to understand, we need to involve the users also to evaluate the models with right data, wrong data, such kind of things. So when users are evaluating, they will see their business requirement also, compare with that also.
Okay. Got
Means
it.
internal testing will happen it with the development team and testing team, but later on there is a pre-UAT need to happen it before the UAT, right?
Yeah.
What is
Yes.
pre-UAT? The users will sit in
Uh,
the QA environment. In the
yes.
QA environment, they are going to test with their test cases,
Yeah.
right? Then
Correct.
slide 13, explainability and governance. What to say? Imagine a customer calls the bank and asks, why was my transaction blocked? Let us say if my transaction is blocked, the bank cannot simply say because the AI said so. No, not that response need to be given. We need to understand why the model considered the transaction risky. It means I need to the customer, the banker need to understand the model functionality also internally how it functions for fraud data,
Okay.
non-fraud
Yes.
data, right?
Mhm.
So
Yeah.
bank also can predict fraud apart from customer thinking that customer might say I did not do this is not my transaction, then bank need to
Okay.
see verify that also from where it happened, whether it happened from the same previous IP addresses from say previous laptops, because IP is also going to be stored in the system, right?
Yes. Yes.
So transaction happened from your laptop only, you are denying it, it is not my transaction, how come it is? Bank
Mhm.
can argue with that, right?
Yeah. Yeah.
So such kind of things also we need to see. We need to understand why the model considered the transaction risky. And example, the system might identify unusual transaction frequency, a new device, an unusual location, and an unusually large amount. You might use mobile phone, you might use laptop or some other device also. It need not be same IP address, can be used always. But frequently our devices are going to be stored in the system. You
Okay.
know that OTP, how it
Yes.
comes. Let
Yeah.
us
Yeah.
say if the Google password is missed out, immediately it will send the message to the mobile, right? And you need to press particular code that numerics will be there. You press this one in your mobile if you are clicking on that, then it will be activated. It will say such kind of multi-factor authentication will happen. It here also the devices are going to be stored it, and it is easy the regular device transaction has come from that device or other device. So then if it is
Mhm.
coming from other device, other location, other IP address, then it is suspicious transaction.
Okay. Okay.
So these decisions, these analysis need to be done by the users also along with the technical people.
Mhm.
Am I right? Because these are the
Yes. Yes.
business decisions. We also need to know which model version was used. There are different versions. Why means different models cycle wise we are updating it, upgrading the models because of data sets used, because of the user functions are changed. All these scenarios testing different versions we are making. So
Mm-hmm.
version control is very much need to be followed as a standard and guardrails and also
Mm.
governance also,
Yeah.
right?
Yes.
So simple analogy from slide 13 is explainability and governance. See, explainability means all this we discussed it.
Mhm.
One is
Yeah.
user understanding, decisions making, and model versions making. Then each model, if it is rejecting the transaction, why it is rejected, explanation need to be there under log files. Okay. Simple analogy is if a doctor gives a diagnosis, you normally want to know why AI-based decisions also need a level of explanation and accountability. These are the common things need to be there in AI models in the log files. That kind of system need to be designed by the model developer, AI developer.
Okay.
See, there are DPDP Act is there in European countries. DPDP Act demands you need to have explainability in the system.
Mhm.
That's where the audit is going to happen it in every company with DPDP. Even Indian AI auditing is there as per the compliance, government compliance. There also they insist each transaction, whether it is passed or rejection, we need explainability. It
Okay.
means log files making for every operation recording is mandated in AI. In a bank transaction, there used to be log files, but those log files were having different entry points. But here, the business justifications need to be recorded under explainability clauses.
Okay. Okay.
That's where explainability and governance. It is part and parcel of the governance, explainability, right? So
Yeah.
a trustworthy AI system should be able to explain, document, and defend its decisions. So it need to protect the decisions. I rejected this transaction. Example, model set. So reason is that the current IP is not found in the past logs, his previous log systems or devices, and that is the rejected. Another thing is location is different. It is not regular location, it is out of the country and currently is staying in India, and how it can happen, the point of transaction from US or Canada or some other country,
Okay.
right? So that is the explanation need to be given it, right? In slides 14, layer 3 outcome is what? Transforming to layer 4. This is the last one, I think, right? We have 14 slides. Am I right?
Yes. Yes.
So last one. We have
Yes.
now
Yeah.
completed the model development stage. We have a
Okay.
trained fraud model candidate. We have evaluated its performance. We have selected a decision threshold. We have documented the model and established how its predictions can be explained. That's where we have seen the
Yeah.
explainability and all these things. But we are
Okay.
not finished. Why? Before this model is allowed into a real banking environment, it needs to go through the next stage, which is validation and safety. That is the next layer, right? As per AI
Yeah.
life cycle, 7 layer
Yes.
cycle. So strong closing statement in this slide is, so layer 3 doesn't mean we built an AI model and we are done. It means we have produced a model candidate with enough evidence to move into next stage of AI life cycle. So layer
Okay.
2 is trusted data is made it. Layer 3 is fraud model candidate is there in this model development layer. It is talking about. Okay. Then layer 4 in the model development, prove it it is safe, reliable, and ready. It means we need to confirm it by following a lot of governance and guardrails, explainability, all those things. The layer 3
Yeah.
material defines the final outcome as a trained, versioned model candidate with performance evidence, explainability, and documentation, ready for layer 4 evaluation purpose. Yes.
Okay.
So the complete layman story is first we understand what fraud problem the bank wants to solve. That is the objective of this particular layer. Then we
Okay.
collect and prepare the right data. Once we have trusted the data, we teach AI using historical examples and legitimate and fraudulent transactions. From where it comes, historical examples, we need to prepare a test data with more fraudulent transactions with some right transactions, right? Then legitimate examples of legitimate need to be prepared, and fraudulent transactions
Yeah,
need to be
okay.
there in that, right? It means we need to prepare the customer history. Within that, more fraudulent transactions need to be there to test the model correctly. Incremental, we
Okay.
are building the model. Each cycle, each version, we need to keep on testing with the different data sets. Data sets also need to be there under version control. It means set 1 is different, set 2 is different, set 3 is different. Because it has got parameters to evaluate it with combinational data.
Yeah.
So we create useful signals from transactions, train multiple models, because version control we made it. From that we are getting versions and test them, compare them and improve them repeatedly. Which model is best also we need to evaluate it, right?
Yes. Yes.
We don't, how you are going to evaluate it? That model is different, better than this. Depends on the data, depends on the explainability, all those things. We don't
Okay.
look only at accuracy because missing fraud and incorrectly stopping genuine customers both have consequences. It means customer transaction is blocked, it means I'll get offended basically. Then what happens? I'll not use that particular card. Okay, I'll go to another bank card and I'll use it. They are losing the money back then.
Okay.
Am I right?
Okay. Yes.
It means they lost the business.
Yeah.
So everything is very cautiously need to be made in the production.
Mhm.
So the selected model produces a fraud risk score. The bank then uses that score and its policies to decide whether to allow, review, or block a transaction. It means decisions need to be done with evaluations by the model,
Mhm.
right? So
Yeah.
finally, we document and explain the model so that the bank understands how it works and can move it into next life cycle stage, validation or and strategy. It means while moving each layer wise, we need to see that script is working perfectly for different versions. Okay. So
Okay.
each layer wise, they need to evaluate the model perfectly. Then only the process is followed, governance is followed, controls are made, and user also will be happy. So, so layer one, what it is, what problems are we solving? That is problem and use case and problem. Do we have the right data in the data layer? Then in model development area, can we build the right intelligence within the model? We have seen different evaluations for the using data sets, using business rules also. Then intelligence is made within the model. Can we
Okay.
trust and safely use it in the next layer? It means validation, safety, we are using it in the layer. That's where we are working in these layers. Okay.
Okay.
So
Okay.
you got the clarity, right, for all these slides. How much size is
Yes.
there to design the model?
Yes. Yes.
Okay. Developing code is different. First, we need to understand the design, standards, governance, controls, and auditing process. Which one to audit? Now
Okay.
you tell me, as ITSM person, what are the things we can audit here if model is ready?
Yeah.
I'm asking the questions really to you as
Okay.
per
Okay.
the discussion.
Yes. We can audit the
Hmm.
transactions which were already the data which is already collected or the transactions made.
Now, one more question. What are the defects can be there in data? What are the defects can be there in the model development?
Uh, something abnormal behavior from the customer could be a defect in the data.
No, abnormal behavior of the customer or transaction behavior.
Transaction, I will, it is transaction behaviors.
Okay, okay, okay. Right. So examples,
Uh,
live examples.
Live examples, uh, maybe similar transactions, multiple payments to a same merchant. That's where the AI would confuse whether it is a valid payment or if it is invalid. Well, I would say the fraud payment.
How are we going to insert the logic here in the model? What are the business rules need to be imposed?
Uh, Business
We
rules
went
to
through
be.
slides, right? Slides are there. You have that ChatGPT script, right?
Yes, yes.
Just go through and answer to me.
Okay.
You use the open book, no problem.
Yeah, yeah, sure, sure, sure. Okay. Um,
Go to 7, 6, 8. 8 is the
okay.
conclusion.
You're talking
6 and
about
7.
business rules, right?
Yeah, business rules
Business
can
rules.
be there
Yeah.
to filter the data and take a decision by the users.
Correct. So, yeah, a
Examples,
predefined banking
live
decision contains the contains that converts AI risk score and other information
mm,
into action. For example, suppose the AI model gives fraud score of 85 to 100. The business rule could say, 0 to 40 is a low risk, 41 to 70 is a medium risk, and 71 to 100 is a high risk. So, yeah, the separation between the model score and the business action is important in the layer 3 architecture. The
mm.
source, the model output as a fraud risk score, and then shows the threshold being converted into, you know, uh, block decisions. So business rules can use more than AI scores.
Okay, fine. So now we have made very detailed explanation of the content. Another slide walk through technical front. These all are basically what to do is just a moment. Let me walk through. Let us do one thing. Let us walk through this content also. This is technical side, technical design side. It is given content here as per my
Yeah.
prompt.
Yes.
Um, I need a very detailed explanation of the content on each slide. I asked it. So, um, so what it says is overall story. The audience should have leave layer 3 understanding one fundamental idea. Layer 2 gives us trustworthy on data layer. AI-ready banking data. Layer 3 uses the data to build, test, improve, and explain and package a fraud detection model that is ready for independent validation. It means these are the parameters, these are the steps they need to follow. Means data need to be there, different data sets, and building the model, testing the model, improving it, explaining the reasons, and package a fraudulent detection model. And it is ready for independent validation, layer 4, right? The source material positions layer 1 as the business problem layer, layer 2 as the trusted data foundation, data layer 3 as model development. Because we supplied the previous demos slides also and asked it to come up with some kind of
Yeah.
explanation, right?
Yes.
Now, A life cycle layer 3, if you see, it is a model development, basically. What is slide means, this is a entry point into layer 3. So slide 1, we have already completed two important activities. Layer 1, problem definition, which has got with the determination what fraud problem the bank wants to solve. Yes, we identified it. Bank fraudulent transaction need to be identified. Who the stakeholders are. Yes, we identified what the business expects from this automation, AI automation, then what constraints exist, what success looks like. Okay, then data layer is what? We then established the data foundation, banking data sources. Yes, you came up with some architecture, data architecture. Then there you also identify data ingestion is what with real time and batch processing. Then validation, we discussed it. Then raw data, clean data, curated data. What are the differences in three of these? We identified it in your solution demo. And feature preparation, we made it. Then labels, we made it. Security and governance, we identified it for data layer. Then we made it as AI-ready data after having all these filters, all these controls and governance steps, right? The source explicitly described layer 2 as moving through banking data sources for ingestion, validation, raw and clean and curated data, and features preparation toward an AI-ready dataset. So categories identified it, those are converted into features for the model, right? Now layer 3 asks, can we use this trusted data to build an effective fraud detection model for development purpose? So what model development means to a layman is, imagine that a bank has hired a new fraud analyst is an employee example. Okay, we give that analyst thousands of or millions of historical transactions. Some transactions were legitimate, some were fraudulent. Why? Because the past history data we gave it to the analyst to identify, to evaluate this particular work, how to identify fraudulent transactions. They take a decision, such kind of things. It is a kind of training also they give to the analyst, right, in the beginning with this activity. Some were fraudulent. We show the analyst the patterns associated with each. Yes, what are the data patterns? Over time, the analyst becomes better and at recognizing suspicious transactions. It means immediately he will take a decision, right? Because we trained him with the data. It means how you are training the human in your work culture, with your work activities, with the data pieces, with the process steps, with the standards. The same way, software AI model need to be trained it, right? Then it will have its own decisions after having this training. Machine learning performs a similar process mathematically. The difference is that instead of a human manually studying every transaction, the model learns patterns from data. So, how this user learned it? He identified different categories of the transactions, different customer categories also, segregated that. Then he reviewed the data. Then he identified fraudulent transactions. The same way, we are working with feature engineering concept in the machine learning where different features are segregated and identified by the model to find the fraudulent transactions. What the architecture is doing, the basic flow is AI-ready data, features, training, evaluation, model selection, and explainability, fraud model candidate. Then layer 4 is validation and safety. This is exactly the layer 3 positioning defined in the source material as our source material basically. Why this slide matters, the most important message is we're not building AI for the sake of AI. We are building intelligence to solve the business problem defined in layer 1. See, if you see 2 years back or more than 2 years back, many people built AI products for this purpose only, for the sake of AI. They did not follow the rules. They did not follow any of these things, whatever we discussed so far. That's
Okay.
where bubbles are happening. That's where failures are
Mhm.
happening. That's where budgets are getting eaten up. That's where they're firing the legacy people to reduce the cost, IT budget cost. So proper
Okay.
planning is not there. Proper governance was not planned yet. That is the issue. So the model therefore has to satisfy business, technical and operational requirements. That is the one. Then transition to slide 2 is say now that we understand where layer 3 sits, let us look at the complete journey from AI ready data to a fraud model. Okay. So what is slide 2 here? From AI ready data to fraud model is the layer 3 architecture overview we are seeing. Then source recommends this as the complete ML development pipeline. Then prepare, engineer, label, train, evaluate packages. It means, finally we packaged it and kept it ready, validation, safety, layer 4, purpose, the final thing. The more detailed flow is curated data from layer 2, then feature engineering, features are identified in the data sets itself, then train and validation and testing is done in layer 3, then model training is done, evaluation is done, model registry is done. Registry is nothing but you are versioning that model, right? In the version control, you are saving the files. And then candidate fraud model is ready, right? Then explain each stage. Curated data is what? This is the trusted data produced by layer 2. It has already gone through data preparation. We don't want to train a fraud model using dirty or unreliable data. It means we complied with all these things with following data governance, right?
Okay.
There is no unreliable data. All are reliable data only. We prepared it.
Mhm.
So feature engineering is what? We convert useful information from transactions into signals and model can learn from, for example, transaction amount. Amount wise also feature is there. That is one of the feature of the data. Then transaction frequency, how many times it happened in a day with the same card for the same customer. That is the frequency is feature. The location is the feature, device is the feature. Obviously, why device is the feature? They might use different devices. IPs are different. For mobile phone, IP is different. Laptop, it is different. iPad is different. Such kind of things, right? Then merchants from the source who is making the bill on our credit card, that merchant need to be there. Let us say if you purchased Amazon.in, it is US company. If you are purchasing Amazon.com, it is Indian company. You are doing regular transactions with it. But if you are done with Amazon.in, that is a suspicious transaction, right? Because location wise. Then merchant wise. Yes, authentication. So authentication is not done. Overseas transactions, all most of them doesn't have multi-factor authentication like OTP. In India, how we have a set, right? Then customer history. So customer history also is one of the features. Velocity. It means for model, all these features data is very important to test the paths of the program, different paths, different validations, all these things. These are called features within the data, fraudulent data. You got it?
Okay.
Features means,
Yes.
okay, it means in every domain, we have features. Those features need to be fed to the machine learning programs. Then
Mhm.
according to that features, it is going to analyzed through algorithms within the program. What are the algorithms going to happen? We are going to see in the Python program, not now. We are discussing about the domain function only, not technical function. You got it?
Yes, sir.
Now, train and validation test, what were we doing here? We don't give all our data to the model and then test it using same data because we separate the data so we can determine whether the model can actually generalize it. Means features wise we can give it. See, initially you can give transaction frequency or location, one feature data. Okay. Then for same customer on multiple locations it happened on the same day, suspicious transactions are there on his name. If you compare the customer history, right? That's where it gives, we have to give data set wise. Then model training is what this is where machine learning algorithm learns patterns as
Okay.
in the training. In the training, feature wise, we are going to supply the data sets, right? Then evaluation. We measure whether the model is actually detecting fraud. It means the right fraud data is identified or not, we are evaluating the model. Okay, you need to supply that feature related data and test it. Then it will give the results, right? We maintain a controlled record of the model version and it's associated with that. Let us say I have a
Okay.
feature location wise. Location wise tested data will have a different label. Location tested model version 1 in location tested, that is separate. Okay, that feature. Then after that, here another feature is that. Then device wise tested model version 1, version 2, like that. Such kind of effort is required to train the model, to test the model also. That's where the AI models testing, training and testing is a big phase. Across the project life cycle, it will take 30 to 40% of the effort. Okay. Then model registry. We maintain a controlled record of the model version and its associated information. We discussed it. Feature wise, if you take a decision to test that, as data can be segregated into data sets, and it is going to be registered under that particular feature model. Okay. Model candidate. The result is not automatically production ready. Yes, it is not, it will not be. It is a model candidate. The model candidate for particular features. It can be a single feature, it can be multiple features, all those. That distinction is important because segregation is there with the features. The candidate must subsequently pass layer 4 validation and safety, then only. Authentic architect's key message is here the model is the output of a controlled engineering life cycle, not simply the output of running an algorithm. Means what is the controlled engineering here in the life cycle? We use a data layer. With that, we got the cleaned and reliable data. We got different features, segregated data sets, and we are testing the model feature wise. Then finally, we are going to put in common data, all features. Then we are going to test one more round, final round, before going to safety and validation phase, layer 4, right? Then slide 3 is define the fraudulent model objective. What the model must answer. The central question is how likely is the transaction to be fraudulent. It means we need to answer that. The source explicitly defines the model objective as identifying suspicious transactions early and assigning a fraud risk score. So what is the risk score? Imagine the model gives transaction a risk score 12. Transaction B score 46. Transaction C score 96. Now you compare the explanation of this particular prompt script and previous prompt script for this particular slide. You are identifying the difference? Bharat, you need to answer.
Yes, yes, sir.
How it is elaborated here,
Yeah. Okay,
right?
transaction
The
one,
number
risk score
doesn't
12.
necessarily
Yes.
mean the transaction C is definitely fraudulent, but we need to assess
Correct.
it.
Yes, yes,
The
yes.
business decision need to be taken, right? With the score,
Yes.
risk score.
Yes.
Based
Yes.
on the patterns, the model has learned this
Mm-hmm.
transaction looks significantly more suspicious. But suspicious transactions, who need to approve it as fraudulent transaction? The stakeholders. Am I right?
Okay. Okay. Yes.
So it means finally, whatever you are designing the model, it need to come into this conclusion: suspicious transactions,
Mm-hmm.
right? So the important architecture is fraud model risk score and low, medium, high identification. Allow or review or block transaction decisions need to be taken by the user. The flow is
Yeah.
explicitly recommended in the source material. Okay. So why
Okay.
not simply say fraud, not fraud? Because the banking decisions are more complicated. A transaction may be clearly legitimate, somewhat suspicious, highly suspicious. The bank may therefore want different actions. So the low risk, medium risk, high risk, such kind of things. The important business connection is model has to support the layer one objectives, detect fraud, reduce fraud losses, avoid unnecessary disturbing genuine customers, respond quickly enough for real-time transaction. These we discussed it, but here it is a separate analysis it is done. Avoid unnecessary disturbing genuine customers, respond quickly enough for real-time transactions. So it means real-time fraud transactions. It means decisions making is very essential here. Stakeholders, right? And another thing, how the stakeholders can get the reliability on the model, whether really it is identifying the suspicious transitions in the model testing itself, they need to identify, they need to take a decision. The model is
Okay.
working correctly.
Mm-hmm.
Means
Okay.
both ways, both sides it is there, right? On data side and model evaluation, right?
Okay.
So what we'll do, we'll stop at this slide, at slide 3. We'll continue in the next session, right? You
Okay.
got the
Okay.
clarity, right?
Yes.
Now,
Yes. Yes.
so difference you are getting it.
Yeah. Yeah. Yes, sir.